So a quick refresher on this was simplifying rational expressions, right? So the first one, number 7, is just your numeric values. So for a question like that, we're going to look at it's just one term, not just numeric. There's numeric and variable. But what number goes into both 18 and 60? Yeah, 6 can go into both. So this would be 3 times, and this would be 10 times. And then x to the second and x to the fifth, there would be 2 less. And so I'd get 3 over 10 x to the third. For 11, now you had ones in which you had to factor, right? So there's multiple ways to factor the top. You could either do trial and error or you could do first and last. But because they're prime, I would say they're both pretty easy to do. I feel like most of us do first and last. I'm going to do that. 3 times -2 is -6. And then you're looking for the factors of -6 that sum to this middle term, which is -1. And that's -3 and +2. You're going to replace that middle term with those 2 terms. And then you're going to factor by grouping. So from the first one, we're going to take out a 3x, and you get x minus 1. Then take out a 2, you get x minus 1. And you end up with x minus 1 times 3x plus 2. And that's your numerator. Then you want to factor the denominator. So I would say, again, you have choices there. You can do first and last from the way that it is. Or you can rearrange them, putting the x squared at the front, and then even take out the negative. So if you're doing that, or let's say how many people did first times last on the bottom, or would choose to do first times last? How many of you would rearrange it and then take out the -1? Okay, so I'm going to do that one just because that was more hands. So if I'm going to rearrange it, I get -x squared minus 4x plus 5. Be careful with your signs when you're rearranging. You can even do first and last from here if you wanted to, or you can take out the -1 and it changes the signs of everything after it. And then I'm looking for the factors of -5 that sum to +4. So -1's on the front. X plus 5, x minus 1 would give you that +4 in the middle. And that's your denominator. And then from your updated and factored terms, you can cancel out the x minus 1s. And I end up with 3x plus 2 over -1 times x plus 5. Or if you had it the other way, you may have done 3x plus 2 over -x minus 5, which is also completely fine. Questions on either of those? Yep.
So I don't have to keep them in the parentheses?
You mean the -1 on the bottom?
No. I mean, like, in general, like, for, like, 3x plus 2.
Not if it's the only term. If there's more than one term, you have to keep them in the parentheses.
Would it still be wrong if I put them in parentheses?
No.
Oh, okay.
No.
Can we go over the web quiz?
All right, so Chapter P, Section 5, Part B, takes what we did yesterday or on Monday and takes it to the next step, which is now multiplying and dividing rational expressions. So now you're going to have 2 fractions, okay? If you're multiplying, you can cross-cancel. If you're dividing, we're going to keep, change, flip, and then cross-cancel. But for these, there are times in which you're going to be factoring 4 times because you're going to factor for each of the parts of each of the fractions, okay? So again, if factoring is where you're lacking, like if you did not do well in yesterday's quiz, then you definitely need to catch yourself up because this is going to continue to be super important. So multiplying and dividing rational expressions, we're going to factor each part of the fractions. So there could be up to 4 parts that you're factoring. For multiplying, you can cancel the numerator and the denominator like we did yesterday, or you can cross cancel. So I can do the top left with the bottom right, the top right with the bottom left. And then if you're dividing, you're going to stay, change, flip, or keep, change, flip, which means keep the first fraction in the order it is, change your sign from division to multiplication, and then flip the second fraction. And then you're going to do the same thing, cancel either top to bottom or diagonally. So they're going to look like this. And it will literally just say simplify. You got to pay attention to the sign that's between them to know what to do. So with number 1, I want to go, there are 4 parts that I have to factor if I can. The top left, which is x minus 2, can that be factored?
Yeah.
X minus 2 is already factored, right? Then I go to x plus 3. Can that be factored? No. Then I go to x squared minus 9. Can that be factored?
Yeah.
Yes, that's called what? Difference of 2 squares. So this would be x plus 3 and x minus 3. And then the bottom right, can that be factored? X plus 4? No. Now we cancel, and I can cancel top to bottom or diagonally. You cannot cancel side by side. So I can cancel one of these x plus 3s with this x plus 3. And then I've got an x plus 2 across from an x plus 4. That can't be canceled. And an x minus 3 in the top and x plus 4 in the bottom can't be canceled. So then I'd multiply out what's left in my numerator, which is x minus 2 and x minus 3. And then I'd put it over what's left in the denominator, which is the x plus 4. And we leave it like that. You do not want to FOIL out your numerator. You want to keep it in factored form.
We're like never gonna have to like FOIL it out.
Nope. All right, go to 2. Again, you're going to go to each spot. So, and again, this time there's only one to be factored, which is x squared minus 9. This becomes x plus 3 and x minus 3. And this time the x minus 3's cancel diagonally. And what? The x plus 3 in the top and the bottom cancel. The only thing left in my numerator is the x plus 4. And there's nothing left in the denominator, which means this would be my answer. So you don't want to put it over 1. You want to simplify that and just keep the numerator. Joey?
If there was like 2 x minus 3's in the numerator, can you cancel it out?
You would only cancel one of them out. Is that what you're saying?
Like, if in one of them was x minus 3 and then in the other numerator was x minus 3, can you cancel?
Yes.
Okay.
But only one. Like if this was x minus 3, I think this is what you're saying. Over whatever times, and this was an x minus 3, and then this was an x minus 3.
No, like the denominator is just something random. Can you cancel like?
No. Okay, so if this was different,
Yeah.
you cannot cancel side by side.
Okay.
That's the one thing you can't do. You can do diagonally, and you can do top to bottom. You cannot do side by side. Okay, good. I'm glad you asked that question. All right, then we just bump up the factoring. So in question 3, we are going to factor 4 times. For 2x squared plus x minus 6, how would you factor that? What would be the process? Valerie?
2 times negative 6.
So first times last, and I get 2 times negative 6, which is negative 12. Factors of negative 12 that sum to positive 1. What are they? Positive 4, negative 3. And then I'm going to replace the middle term with that. So 2x squared plus 4x minus 3x minus 6. And then we factor by grouping. So you take out of the first set of parentheses 2x, and it's x plus 2. Take out of the second set of parentheses negative 3, and it's x plus 2. And then the x plus 2 is common, so that becomes x plus 2, and group together what's left, 2x minus 3. When there's this much going on, you may want to rewrite your factored fraction. So if I was to do that, the top left would be x plus 2 and 2x minus 3. Just so you can see it a little bit clearer. Then I'm going to go underneath there. So x squared plus 4x minus 5 would factor into x plus 5 and x minus 1. That's the denominator of the first fraction. And then it's multiply. And I'm going to factor the top right. How do I do that? Hadley.
Do you have to, can you just do like the thing and just take them out because the x is cubed?
All of them have an x, so the first thing I'm going to do is take out an x. Yep. And I would get x squared minus 3x plus 2. And then can I factor that further?
Yeah, and then you just do x minus 2 and x minus 1.
Good. And that's the numerator on the second one. And then I have to do the bottom right. How do I factor that, Valerie?
3 is common factor.
Good. Which is what?
2x.
2x. And I get 2x minus 3. Everybody with me so far? Okay, so now I'm looking at the factored form of these fractions. And what can I cancel, Valerie?
X minus 1.
X minus 1 from here and here can cancel. 2x minus 3 from here and here can cancel. Anything else? Good. The x here can cancel with the x here. So because it was only multiplication, right? It wasn't part of a sum, I can cancel out part of it. So now in my numerator, I've got an x plus 2, an x minus 2. In the denominator, I've got an x plus 5. So my answer is x plus 2 times x minus 2 over x plus 5. 2 times x plus 5. Thank you. Joey.
How did you get the denominator for the purple one?
Take from here, so from the 4x squared minus 6x, take out a 2x because it's the greatest common factor.
I'm sorry, the numerator.
Oh, the numerator? I had to take out an x first, and then I'd get x squared minus 3x plus 2, and then that, you're looking for the factors of positive 2 that sum to negative 3, so it's x minus 2 and x minus 1. Questions? So yes, there are going to be times in which you have to factor 4 times. That's why factoring is so important. Okay, look at 4. Can any of this be factored? No. So what can we cancel? The x minus 1s and the 5 into the 25. The numerator has nothing left. Does it mean I put a 0 in the numerator? No, you put a 1, because when we cancel, we're actually saying it goes into itself once. So it would be 1 over the only thing left in the denominator is x minus 2. And a 5. You guys are doing so good. I'm just testing you. You're doing so good. Yeah, uh-huh.
Wait, how did you get the 5?
Because the 5 goes into the 25 5 times. So you can cross, you can go top and bottom, any of those. Questions? All right, so if I factor the top left, I'm looking for the factors of negative 6 that sum to negative 1, which are x and minus 3x plus 2. The bottom left, factors of positive 9 that sum to 6 would be x plus 3 and x plus 3. The top right stays as it is, so these are gone. The bottom right is x plus 2 and x minus 2, different to 2 squares. Now I want to start canceling. So I can cancel the x plus 2 with the x plus 2. I can cancel the x plus 3 with the x plus 3. I cannot cancel an x minus 3 and an x plus 3. Okay, those are different. And the x minus 2 is there. So in my numerator, I've got x minus 3, denominator x plus 3, and x minus 2. And I end up with x minus 3 over x plus 3 and x minus 2. So So can't cancel a plus and a minus. You can, let's just say an opposite shows up. So like if it said something like x minus 3 and over here was 3 minus x, those are opposites. So it works just like when we simplify our fractions. We cancel them out and one gets a negative 1. And it doesn't matter which one. You can put it in the top, you can put it in the bottom, okay? But when you're canceling opposites, okay, you can cancel, but one's got to have the sign change. So just be careful. Raise your hand if you got 5 right. Okay, great. All right, now we get into the division ones, right? So the only thing different is the very first step. I would recommend, so you can do this 2 ways. One is factor first and then say change flip, or say change flip and then factor. I recommend flipping first because it tends to be we get going so much in that factoring. You've done 4 different types of factoring that you forget at the end to flip it, or you're flipping and there's more writing involved. So my recommendation is the moment you see that division sign, you rewrite this question so that it becomes x to the third. Man, it's this question. X to the third minus 8 over x squared minus 4. So that's the keep part. Change the division sign to multiplication, and then flip the second fraction. So x to the third plus 8 goes over x squared plus 2x plus 4. And now I factor. So the top left is what? Good. Difference of cubes. So I would cube root the x to the third, I get x. Cube root the 8, I get 2. And then the first set of parentheses is those 2 terms. Then I square the first term. I multiply the 2 together. I square the second term. And SOAP. Same, opposite, always positive. Now that's gone. The bottom left, difference of 2 squares, x plus 2, x minus 2. The top right is the sum of those same cubes. So I can literally write out all the same terms. I just need to go back and change the signs. So this would be x and 2 again, x squared, 2x and 4. And this time it's a sum, so same, opposite, always positive. And then the bottom right, there are no factors of 4 that sum to 2. That cannot be factored. With me so far? Now comes the canceling. So I can cancel the x minus 2 in the top and the bottom. I can cancel out the x plus 2 in the bottom left and the top right. And I can cancel out the x squared plus 2x plus 4 in the top left and the bottom right. So all that's left in the numerator is the x squared minus 2x plus 4, and nothing is left in the denominator. That's my answer. All right, so all I did the first time was go through and just rewrite these as their multiplication. So keep, change, flip each one. So for the first one, for 7, the top left is the difference of perfect cubes. I would cube root the x to the third. I would cube root the 1, and I get x and 1. And then I put those both in the first parentheses. I square the x, multiply the 2 together, square the 1, and then it's same, opposite, always positive. The bottom left, and that's gone. The bottom left is x plus 1 and x minus 1 because it's the difference of 2 squares. The top right, factors of 1 that sum to 2 are x plus 1 and x plus 1. That's gone. And the bottom right can't be factored. There's no factors of 1 that sum to 1. Then we're going to cross cancel. So the x plus 1 here can cancel with the x plus 1 there. The x minus 1 here can cancel with the x minus 1 here. And the x squared plus x plus 1s can cancel in the top left and bottom right. And all that's left is my x plus 1. Raise your hand if you got that right. Good. Okay, second question on this one, but question 8. I already flipped it. So the only thing that gets factored here is the top right. This becomes x plus 1 and x minus 1. That's gone. I can cancel out one of the x's. And I can cancel out the x minus 1. And I end up with x plus 1 over x. And we cannot cancel the x into the x, right? Because that's a sum and you can't cancel into part of it. Questions on that one? All right, and then number 9, I already flipped it. I'm going to factor the top left. This would be x plus, or x minus 7 times x minus 7. The bottom right, x plus 7 and x minus 7. The top right is already factored. The bottom right, I could take out the 3, and I get 3 times x minus 7. And then the x minus 7s cancel top left and bottom right. They would also cancel top left and bottom left. And then the x plus 7s cancel, and there is nothing left in the top or the bottom. Well, the bottom just has the 3. Yeah. Sure. Rodrigo.
Would we ever have a question that was like equal 1?
Sure. I mean, everything would cancel at that point, but yeah. Not likely, but it does happen. Questions? All right, so homework is on WebAssign and Canvas. It's due tomorrow, okay? If you have questions, because we're about to run out of time, but if you have questions from last night's homework too, remind me, I'll go over that tomorrow, okay? And then